Hey everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 65. And today I have total imposter syndrome as I am currently sat here in a virtual room recording with Scott Hunter, Mads Torgersen and Dan Roth. So thankfully it's not live so I can edit out any stage fright moments I might have. So yeah, big warm welcome Dan and Mads and welcome back Scott. I think it was only a few episodes ago since we last spoke.
Yeah, that was the Ignite time frame, wasn't it? Or was it .NET Conf time frame?
It was .NET Conf, yeah.
Yes,
so
it was .NET Conf.
Quite a few interesting announcements there.
Those were the same week. So for folks that are listening, the reason I mixed them up was because they literally were the same time, the same week, same channel, same everything.
That must be one busy week.
I was going to say for us, Dan, it's going to start back up again. I just got the call I had before all of this. We were talking about demos for Build.
Already? Wow.
So Build 2024, May of this year, is already in our minds. And so it seems like you just stop one and you go to the next one. So we're all getting ready for the next thing. So these folks are going to be working on .NET 9 and C# 37, and Mads did not smile.
Oh, I'm looking forward to Build. I like this sort of semi-annual heartbeat that we have now of having a place where we cast the vision and show the early demos and so on, and then the big release towards the end of the year. This is good fun. I like our cadence.
I saw a blog post earlier and it said about the new .NET cadence and the missing out .NET 9 and going straight to version 10. And I was like, really? And then I saw in the title it said April Fools. So I was like,
yeah.
Okay. For a second it had me. But yeah, it's definitely nice having this cadence. Scott, the first time we recorded, it wasn't last year, the year before the first build. So then was it with Gareth Seth?
Yes.
Yeah, that was good fun. So whilst I'm sure introductions probably aren't necessary because most of our listeners will have heard of you all, just in case, could we just go around the table and could you introduce yourselves to listeners and tell us a bit about what you do?
Sure. I can start since Scott has been here so much already. I'm Mads Torgersen, and I worked for Microsoft for 18 years, and for that whole time, I've been involved in the ongoing design of the C# programming language, and I'm now the lead designer. We still aren't done yet. We keep adding.
And I'm Dan Roth. I'm the product manager on the ASP.NET team for Blazor. I deal with our web UI frameworks and offerings in .NET.
And I am Scott Hunter. I work on the Azure Developer Experience team at Microsoft. After spending like 15 years of my time at Microsoft in .NET, and even as the people building the developer tools and developer services for Azure, we also make sure that .NET is the best language in all those services and tools too.
Well, I definitely agree with that one. So we've kind of all got all our bases covered here. It's kind of, we've got Scott, you with .NET, Mads with C#, Dan with Blazor and ASP.NET. In fact, I'm going to get hate mail from the F# folk, aren't I, for saying that. Maybe not all the bases covered, but we've got most of the bases covered. So in November in .NET Conf, as we mentioned, like Scott and I recorded an episode on the .NET announcements, and we chatted about Aspire and some of the C# 12 features, and also touched on Blazor. But we didn't dig too much into Blazor due to like the amount of time, which actually works quite well because like Dan, you're in the recording now, and that's kind of like your thing. So it'd be really good if we can like dig into some like new Blazor goodness. And also for C#, we didn't cover interceptors, which I think that'd be quite interesting to dig into. And is it too soon to talk about C# 13?
No, we can talk about it.
Never too soon. Never too soon to talk about new C# features.
Oh, they're saying that. What was the version you mentioned before, Scott? Like C# 30?
I said 36. I was trying to see if Mads was listening to me. So I was like, he's like, wait, not the 36 yet.
We're close.
So I guess let's start with Blazor. And even though Blazor's obviously Dan's thing, but this is a group chat, so anyone jump in. We've spoken about Aspire, and like with my fascination of Kubernetes, you'd have thought that Aspire would have been my highlight. And it kind of was, but I'm going to be honest, Blazor was a joint highlight because just all the changes in Blazor with .NET 8 in the past, just being able to use it for like almost like Spark kind of applications where now you can use it for anything, any website. So if I wanted to write my blog or something, I would just use it for that. So I think that's incredible. So for listeners who haven't kind of looked into it, can we talk a bit about what's new in Blazor?
Oh, there's so much that's new in Blazor in .NET 8. .NET 8 was a huge release for Blazor. When we originally set out to build Blazor, I think we were really thinking about Blazor as a alternative to having to write front-end JavaScript when you're already building so much of your application in .NET. But in .NET 8, Blazor now is a full stack web UI offering. You can handle the full spectrum of patterns that you might want to do in your web app using the single Blazor component model. Like in the past, we had MVC and Razor pages for doing server-side rendering of web UI. You send a request, you run your MVC view or your Razor page, you get some HTML back, and then the request is done. That was great for anything that was happening on the server, but for any like client-side interactivity, you typically had to then add in some JavaScript into your app. Blazor, like with Blazor Server and Blazor WebAssembly, gave you a way to deal with the client-side interactivity, but it didn't really do any server-side rendering. It didn't have those like nice stateless scale out characteristics of handling things from the server, and a lot of the simplicity that comes from doing things on the server, right? Like when you're running on the server, you're right there in the server environment. You can access your data. You can use the server resources to generate the presentation layer. When you're operating on the client, that gets all a little bit more complicated. And then, of course, there were a bunch of people that were also still running JavaScript and still do, right? Like if you're a .NET dev, a lot of .NET shops have a companion like front-end JavaScript team that build their front ends with JavaScript. With .NET 8, what we did is we took all of that, like all those ideas, those concepts, and put them into a single unified framework. You can now do static server-side rendering with your Blazor components, get the scale out and the great user experience that comes with server-side rendering, and then you can add in client interactivity by just selectively making components interactive using either the Blazor server model where you have like a WebSocket connection with the browser, or the WebAssembly model where you really push that logic down to the client and run it on the user's machine. So you can do the whole spectrum with one offering. It's now our recommended approach for building web UI with .NET. If you're building a new web app, Blazor, I think, is really where it's at.
I think that's what I love about it. It's kind of before .NET 8, if I had to do, I don't know, just a website versus a web app, so like not a spa. And the Blazor component model is so nice. I missed that when I had to use like MVC or Razor pages or something, where now I can, no matter what kind of website I'm creating, I can use that Blazor component model, which just works so nicely. I guess that just like you mentioned about there's one project now. And that where before, when you were creating a Blazor application, you had to choose, do I choose Blazor WASM? Do I choose Blazor Server? And I've lost track to the number of conversations I've had where I've had to explain those things to people. And the architectural decisions up front at the start of a project, which one's right for this project. Where now it's just one project template, isn't it?
Yeah, you just build a Blazor web app. Like before you always had this fork in the road, like right from the beginning, and people, struggled and were anxious about, which one do I pick? Blazor Server, Blazor WebAssembly. I mean, even in the old world, the component model was the same. Like if you wanted to switch from Blazor Server to Blazor WebAssembly, you weren't having to completely rewrite your components, assuming you insulated your presentation layer from where they were being hosted. You could flip the component back and forth. Blazor components are made to run in any of these hosting models. But yeah, it's much simpler now in .NET 8. Like the story is just go build a Blazor web app, and you have now the flexibility within your application to tweak how your components are running at a per component or per page level. You can just do that as you're developing the application.
Hey Dan, if I have an existing MVC application, can I now use Blazor components with that existing MVC application? Is there a path to do that as well? That's one of the things that I heard in the .NET 8 launch that was most exciting to me was, hey, I've got an existing application, a Razor page app or an MVC app, and I want to use Blazor components. How do I do that?
Yes, of course. Yes, of course you can. So, I mean, obviously people have existing MVC apps and Razor Pages apps. They're probably wondering, like, well, what does this mean? Like, what does this mean for my existing apps? Well, you can put Blazor-based pages side by side with your existing MVC app. Like, it's all one ASP.NET Core application, and Blazor is part of ASP.NET Core. So you can have some routes that are going to MVC views, and you can have some routes that are going to Blazor components, and that can all live happily within the same application. That works fine. You can do deeper integrations as well. Like you can take Blazor components and actually add them to your MVC views or your Razor pages. We have a component tag helper that is sort of a way to bridge between the two technologies. You can say, you know what, I have an MVC view, but I've got a Blazor component I really want to use. I'll just add a component tag helper to this, CSHTML file, this MVC view, and render a component there. So that's also possible. We added a Razor component result in .NET 8. Like in the MVC world, you have all these like action results that you can return from your MVC actions. Normally you would return an MVC view action from your controller actions, but in .NET 8 you can now choose to return a Razor component result action from your action and render a component instead of an MVC view. That's possible. That also works, by the way, from like a minimal API. Like if you just want to have a lightweight route to a component, you can do that. And then lastly, there is always the ability to take a Blazor component and render it as a standard-spaced HTML custom element. In that world, a Blazor component gets sort of shrink-wrapped as just like effectively another DOM element on the page. And in that world, you can really use Blazor components anywhere you want. Like you could render a Blazor component as a custom element in the React app or in an Angular app. You can even technically do it in like .NET Framework-based, web forms app or an old ASP.NET app, because it's just an HTML standard at that point when you use Blazor as custom elements. So there's lots of ways that you can now take the new Blazor functionality and add it to existing apps if you're kind of in that brownfield situation. And if you're in the greenfield where you're starting something new, Blazor web app is probably where you want to go.
That blows my mind that you can have a minimal API that returns a Blazor component.
Yep. Yeah, you can absolutely do that. Just return some HTML.
It blows my mind. You could take a 10-year-old MVC application and put a modern Blazor component into that application. It feels like, Dan, we're actually unifying ASP.NET for the first time ever.
Yeah, it does. Yeah, I mean, we've always had this sort of buffet situation with ASP.NET, to be honest. And, whether it was MVC and what was it, web pages, ASP.NET web pages we had back in the day, and ASP.NET web forms. And then we moved to ASP.NET Core. We moved the MVC model forward, but then we had Razor pages and we had Blazor. Now I feel like we've really kind of unified around a single model. And like you were saying, Dan, the component model, I think, is really key in that story. Like we now have a true composition model for your UI. If you need UI widgets, grids, charts, whatever, there's a whole ecosystem of components you can just go grab as NuGet packages, add them to your application and get going fast. Like be really productive quickly by leveraging that Blazor component ecosystem.
Yeah, I think just the fact that a component, when you're looking at the HTML, using a component, it's just an HTML element. So it's so readable and clean. It's not like there's things that look like some other language. It's just HTML and HTML elements. So it's just really composable and clean and readable. Even if you're not a .NET developer, it's very readable for your designers as well.
Yeah, and C#, right? Like it's one of the things I think is really nice about the Razor syntax that we use in Blazor, and also same syntax, honestly, in MVC and Razor pages, is when you want to do conditionals or you want to have control flow logic, like I want to create a bunch of HTML elements and I want to loop over something to do that. With a lot of templating languages for HTML, you tend to have to learn like a separate templating syntax, like what's the conditional syntax, what's the looping syntax for doing that. In Razor and in .NET, if you know the C# code, which you're having to write anyway for your logic, then you just use that same syntax for handling the control flow in your rendering logic, which just feels really, really natural. And you get that productivity of C# as well.
Yeah, out of all the stuff that came with Blazor and .NET 8, one thing did stand out as what I felt would be a bit of a gotcha for developers that maybe didn't spend time understanding all the ins and outs of it. And that's when you can choose the auto rendering mode. So a component automatically chooses between WASM or Blazor server. If a developer doesn't fully understand that, then the code behind of that component, if that's calling out to, for example, Entity Framework or some backend stuff, which is more designed for the backend, then am I right that that'll work the very first time you call it, but the second time you call it, it's suddenly going to magically break? So I'm kind of wondering whether developers would be confused about that experience.
Yeah, this is a great point. Like, we added all these capabilities to Blazor and .NET 8 that allow you to leverage both the client and the server simultaneously. And that enables you to optimize user experiences in really cool ways, really make the pages load faster, make things interactive when you want them interactive. It does, though, bring some complexity to your application. Like you've got two processes on different ends of the wire that you have to think about. Where is my component actually running? And you need to make sure you're authoring your components with that in mind. So I think like the scenarios you're talking about is you may start out with your component running on the server. Before we even get to auto mode, like I know you mentioned auto mode, but before we even get there, there's even the concept of pre-rendering in Blazor where you send the request comes to the server, you go ahead and render the component immediately. So you get HTML right away in the response. You put that on the screen while you in the background are setting up an interactive state for that component. Interactive render mode is what we call it. And that might be a Blazor server based setup where you're like creating the WebSocket connection back to the server to handle the UI events. Or it might mean downloading the WebAssembly bits so that you can run the component client side. So you pre-render first from the server, but if you're also doing WebAssembly, then it will then render again from the client. So you have to think about that component potentially running in both places, which means your code has to account for that. You can't just go talk to the database from the component code because, well, you're not going to be able to do that once it gets downloaded onto WebAssembly. So you do get into that world now. I mean, you have the option of opting out of that complexity. You can just say, I only want to deal with WebAssembly. I don't want to deal with server. Or you can say, I only want to deal with the server. I never want my code to run on WebAssembly. And that does simplify things at the expense of some flexibility. The case you're talking about is the new fancy auto render mode, which is a way for components to decide which way do they want to render at runtime, instead of that being something you decided up front when you created the project or at build time. And the way that works is we render the component initially using the Blazor server model, right? Like we set up that WebSocket connection so that it can be interactive very, very quickly, almost immediately. But in the background, we're downloading the .NET WebAssembly runtime and caching it in the browsers for future use. And then when that component renders again at some time in the future, Blazor can say, oh, look, I've already got that WebAssembly runtime. I can just move this component now to the client, and that happens at runtime. And you kind of get the best of both worlds. You get the fast load of a Blazor server app, but then you've also managed to offload the work from your server so you get better scale out, better cost characteristics for your server cogs. You do in that world again have to think about, well, my component could run on both sides of the wire. How do I want that to work? If you're on the server, you probably can talk directly to the database. When you're on the client, you need to make it probably an API call. The way you typically manage that is by creating interface abstractions that your components code against, like an iWeather service or an iGetData whatever service, and then you just provide two different implementations of that interface that are injected using dependency injection into the corresponding parts of the app. So that's how you typically manage that. And it is more code than just talking directly to the database, but it gives you that flexibility as a result.
Yeah, I think that really shows. For years with dependency injection, dependency inversion, we've been saying for interfaces, don't give away the implementation details. So don't have entity framework repository or whatever it is. And this really highlights that your interface in that case is just saying what it wants. And then one implementation can be calling your API, and one, if it's on the client side, and one on the server side can be calling actually your database or the entity framework. So I think that's quite nice. But I guess we're talking about all this, and I think a lot of websites won't even need to sprinkle that interactivity on it. I think that's a term I heard in one of the talks. And with this server-side rendering, and you've got is it called stream rendering, where it feels like a SPA, even though it's not a SPA.
Right. Yeah. So we think that there's there's a lot of debates on the internet about the architecture of web apps. Should you be doing things from the server? Should you be doing things from the client? And the reality is there's scenarios for both. I do think there's a case to be made that things swung probably a little bit too much to the client in a bunch of use cases where you probably would have been better off doing things from the server. And the classic user experience where you see this is where you go browse to some app, which is mostly content, mostly forms over data, but you have to sit there for a loading spinner while it's downloading some large JavaScript bundle. And you're like, why do I need that? Couldn't this have been done immediately from the server and resulted in a better user experience? And in many cases, I think that is true. By adding server-side rendering support to Blazor. And by server-side rendering here, I mean just the ability to render a component from the server to HTML. Now, I'm not talking about the fancy interactive Blazor server thing, just traditional server-side rendering. You now have the ability to do that with Blazor. And we think that for many apps, that's probably what most of your pages should be like. Like you only really need to and I think I use the word pay here, often in a literal sense, like you might be actually using server-side resources if you're doing Blazor server. You only need to pay for interactivity if you really need those interactive features. If you're not like doing fancy things like drag and drop or whatever, you probably would be better off with just handling the rendering from the server and doing it in a stateless manner and being done with it. So by default, if you create a Blazor web app, it's actually set up in that way. Like most of the pages in a Blazor web app by default will do static server-side rendering, and then you attribute a component with an interactive render mode wherever it's needed. And maybe there's only like 1 or 2 pages in your app that really actually need that additional support. We added also a bunch of modern server-side rendering capabilities to Blazor in .NET 8 so that even when you're not fully interactive, you still actually get that spa-like feel. One of those features is enhanced navigation, where Blazor will actually add a little bit of client-side JavaScript logic that the framework provides to intercept page navigations and do a fetch request instead. Instead of doing a full document load, we'll send a fetch request to the server. The component will render statically from the server, and you'll get HTML in the response, but Blazor will grab that HTML and then intelligently patch it into the DOM for you. So you don't get that like blip when you move from one page to another. A DOM state on the page can be preserved across navigations. It just feels faster and smoother. Same thing for like form requests. Like when you send a form post, often that means rendering a new batch of HTML from the server, and the browser by default will blow away all the existing DOM and recreate it again with whatever HTML it got back. Blazor can enhance the form request as well, do a fetch request for you, get the returned HTML and patch it into the DOM. Streaming rendering is an optimization when you're doing a server-side render and it's got some like long-running tasks that you also need to complete before the page can even render. Like maybe you need to go to a database and it's a fairly long query and you need to wait like a half a second or a second or whatever it is to get that data before you can even render the page, the response. In traditional server-side rendered apps, that would mean the user just sits there waiting for the browser to load. And they might not see anything because nothing's been sent in the response yet. With streaming rendering on the server, what we could do is we can render the component immediately, get pixels down to the browser, put like some placeholder text, like, loading ... or loading spinners or whatever, while that database query is executing. And then when any of those long-running async tasks, API calls, whatever it is, complete, the component will automatically render again, and Blazor can then take care of taking those additional batches of HTML that got sent on the same response stream and patch them into the DOM for you automatically. So you just get these automatic updates as the content is ready. So you get, again, that smoother, faster, more responsive-like experience without having to pay for the full-on cost of downloading a big JavaScript bundle or downloading WebAssembly or setting up a WebSocket connection.
Yeah, I think a key thing there is kind of all what you said then sounds really complicated, but when you do .NET New and create or file new project and create it, that comes out of the box. And I know is it the weather? Is it still the weather forecast or whatever the example component
is?
The
weather component. Yeah. Don't plan your vacation based off of the weather component. It's just random weather data. But yeah, it's just a little demo page.
But that has this stream rendering attribute, and yeah, it's so quick and it just works. So it's kind of as complicated as this might sound when we're explaining how it works. In reality, it just works.
You just add an attribute, you're done. Yeah, it's for streaming rendering, it's add an attribute. For enhanced navigation and form handling, that just happens automatically. Like you add the Blazor script and Blazor just starts doing that for you. So you get those experiences without any effort at all. Yeah, this is looking under the hood and seeing all the cool engine parts. But when you're actually using it, we try pretty hard to make things simple.
So what does this mean for Razor Pages?
Razor Pages is still there. MVC is still there. Like Razor Pages is built on MVC, so they're kind of in the same boat. There are frameworks that are part of ASP.NET Core, and we know we have lots of users that are using MVC. MVC, I think, has been around now for 10 plus years. Scott, is that when did we start MVC? When was the first version?
First version was 2008.
2008. So yeah, like 16 years. That's a long time. These are very mature frameworks. They've been around for a while, and MVC, honestly, in ASP.NET Core has been, it's been around so long. There's not like a lot of huge innovations that are being added to the MVC itself as a presentation layer. Obviously, you get all the new C# features and the performance improvements that happen in the underlying runtime and web server stack that happens in ASP.NET Core. But it's kind of a baked server-side rendering solution, and people will continue to use it, and they should continue to use it. There's no reason to rewrite your MVC or Razor Pages app into a Blazor app. What you can do instead is you can start taking advantage of the Blazor features like Scott and I were talking about earlier. Just add those features to your existing app so you can leverage those capabilities where they make sense.
So we're going to pause the conversation just for a moment for a quick mention about our awesome sponsor, Track.js, who are helping support the show so I can continue to create lots of episodes. We've spoken a lot before in this podcast about back-end monitoring and telemetry, but what about the front end? Do you know what happens when your JavaScript breaks? I mean, I personally never write bugs, but sometimes browsers are weird and users do unexpected things and we get errors in the production UI. Do you know when that happens? I've got to be honest, for a lot of my projects, I wouldn't. Well, Track.js is a fantastic tool that monitors errors from your end users, showing you a story of exactly what happened that led to that error. It gives you actionable observability to what's happening in the client side. So check it out at trackjs.com. So I'm kind of aware that like we've also got Mads and Scott on the call, and so that's like C# and .NET, and you've got ASP.NET. So presumably lots of different teams involved. There's a big overlap because obviously Blazor is using C# and .NET. So is there any challenges with as you introduce those new features?
There's plenty of challenges. Fortunately, we have very good and talented engineers that work very hard to handle those challenges. But yeah, it's actually amazing the level of cross-team collaboration that goes into shipping. Something like Blazor, which is at the kind of a leaf node in the stack, right? Like that's at the very application development layer. Blazor involves ASP.NET Core, obviously. So there's Kestrel and the middleware pipeline, all those features. We work very closely with the folks on the .NET runtime team on the WebAssembly support. We have a whole separate team that handles building that runtime and adding the WebAssembly tool chain. And they did a lot of great work in .NET 8. Like we now have partial JIT, just-in-time compilation support in the .NET WebAssembly runtime, which is super cool. I didn't actually know if that was ever going to happen. We're always constrained in browsers by the specs, by whatever the browsers can do, whatever the web platform is capable of, then we leverage those features. But if we can't do it, then we can't do it. Getting that partial JIT support in was a very clever bit of engineering that was done by the runtime team and resulted in phenomenal performance improvements when you're running your code client-side in the browser. There's, of course, the C# team, but on top of C#, we have our own compiler for the Razor syntax, which compiles to C#, and that's actually handled by a bunch of folks that deal with the C# Roslyn compiler as well. All the tooling, like hot reload and the editor, and getting that great, rich productivity experience in Visual Studio. Like sometimes people ask me, like, how many people work on Blazor? And I'm like, good chunk of the .NET team, really, if you and Visual Studio, if you count everyone up that has a touch point on it. It is quite the collaboration.
Yeah, I can't imagine how, just as a user, obviously, I'm just seeing like the top surface level of the iceberg, but how everything fits together is just absolutely incredible.
It's actually better than it's been in a long time. If you go back and look at the history of .NET, back in like 2002 and 2008 when we did MVC1, .NET was spread all around Microsoft. And it lost some cohesiveness because of that, because the SQL team owned the database APIs, the Windows networking team owned the networking stuff. One of the things we've done over this journey of .NET since 2014, as we started doing the .NET Core up to .NET 8 today, is most of the components in .NET are now built in the .NET team, which means that the cohesiveness that we can actually build by having the compiler team right next to the runtime team, right next to the framework team. That I think is one of the things that's happened over this last, 2014 to now period. I guess it's been 10 years now. Wow, that's crazy. But that is, I really appreciate the fact that we're back together as a group. And even, as I said, I sit in the Azure world, and even the Azure world I sit in is in the same group at Microsoft that builds .NET. And so even we have cohesiveness, and the tools are built in the same team as well. So really, if you think about it, back in 2002, we were spread all over the place. And now we're back to a really consolidated org. And I think that's what enables us to have that velocity that Mads was talking about earlier, enjoying the fast velocity that we have is we're all close together. We can all move together. And that's why Blazor, as Dan said, touches everything. It touches the compilers. I mean, I'm blown away that we have WASM. I'm blown away that we can actually take an ASP.NET application and now ahead of time compile it down to an under 10 megabyte application if I want to. If you told me I could do that 10 years ago, I would have told you there's no way.
Well, I can certainly attest to the value of that collaboration as well. Like the language C#, the languages, I should say, but I can speak for C#. There's sort of by nature, they have to be sort of slow moving in a sense, right? Whenever we add something to the language at that level, it has to be something that is not a fad, is not like yet another way of doing the same thing, right? It has to be something that has longevity because we can never take things out. And at the same time, we have a vast menu of things we could choose to do next in the language and ways that we could choose to do those things. And that is very much guided by our partner teams, right? We'll see that one of the other .NET teams is working in this big push, be it Aspire or we talked about minimal APIs before. And we'll be like, well, that would be a better experience if C# did this thing. That doesn't mean that C# is building a minimal API feature into the language. It means that there's a general purpose feature that now sort of has a concrete scenario that we can use to make it a reality. So now's the time to put that feature into the language for everyone and to use that one or two or three partner teams that will rely on that feature as driving scenarios to help us get the design right. So that's often how the language comes into the collaboration. We will improve it in a general purpose sense, but that is guided by things that would help the overall experience across the other layers.
Yeah, definitely. So I think I'm just aware of the time, and we did say we would talk about C# 12 interceptors, which is quite interesting. I was watching, because Nick Chapsos did a video on this, so I was like watching that, and then I had a bit of a play. I suppose before we start talking about it, can we talk about what it actually is?
Yeah, well, interceptors is an experimental feature in C# 8 or .NET 8, C# 12, and it's likely to not look like that when it sort of reaches its final form. But the idea is we have so many technologies that lean into source generation of various kinds, and part of the bottleneck for generating additional source into your project is how can that generated source code connect with the existing C#, the manually written C#, so to speak. Like what are the language features that lets you stitch in whatever the source generator is produced? And interceptors are sort of like a radical increase of stitching points, if you will, where you can essentially say, hey, let me just generate some code that is what you should do instead of that method call you're doing right there, right? So it'll actually go in and say, for that method call you're doing into minimal APIs, for instance, again, don't actually generate that method call. Call this thing over here instead. Right? So that's why they're called interceptors. Like they really intercept method calls. And it's a weird kind of language feature because it's not very useful to a C# developer directly. Like that's, how do you even say in a stable manner that method call over there, right? That's not and typically you don't need to, because if you want to change what a method call does, you just go and edit the source code. It's only really relevant for automatically generated code that then modifies the behavior of the user's code. Now, when you hear modifies behavior, that sounds probably scary to some people, like, hey, I'm writing this code, and then this thing that's running as part of my build process, or maybe running in the background all the time, will essentially change the meaning of my code. What's up with that? So that's obviously not something that you should generally just do willy-nilly. Like that would be very confusing and hard to debug, but there are some scenarios where it's really what you want to do. One of the reasons why we put it out already in .NET 8 is we're looking at ahead of time compilation as an alternative to JIT in certain scenarios. Then when you have .NET code, ASP.NET is a great example that relies a lot on reflection and of like using the runtime data structures that are meta in a way, that are the reflective meta layer, if you will. Then a lot of what they do can't be done really well in an ahead of time compilation scenario. Like you just can't generate new methods or whatever, because, hey, you were already compiled. It's too late. And so what we can do is to source generate at compile time alternative implementations of that reflective code that use compile time information instead. And then we can intercept the calls you do so that we run that compile time stuff as well. And if we do that consistently, then your code is AOT friendly, as we say, and you can successfully compile it ahead of time. So that's sort of been the driving scenario, but I'm sure there are many others down the line. And it really, if you compare it to something like IL rewriting that is further on the back end, so to speak, it has a lot of benefits to the developer. One of them being that there is, in fact, source code for both the before and after, right? The thing that got intercepted and the code that intercepts it. And that means if you're debugging, trying to figure out what's going on, you can actually debug into the source generated code and see what really happens at the C# level. So it makes it a lot more approachable to the C# developers.
I'm just thinking I'm going to have so much fun with this on April Fools with my current client's code base. Oh no, they might be listening, but also that.
Oh, you should not have shown your hand there.
Pranking with interceptors, is that what this is?
Oh, funny. So for source generators then, is it fair to say that where source generators are additive really, that this allows you to actually modify existing code as well? So it basically means you can do a lot more with source generators.
Yeah, well, technically they're still additive. We've always held the line on not letting source generators directly replace your code. And so it's all down to which features are in C# itself to stitch things together. And we've had various forms of partial evolve over time. Like you're saying, I'm leaving a stub here for source generation to fill in. So with this, it's still additive in a sort of technical sense that all the source code is still there. We're not replacing anything, but the generated source code has sort of C# level directives to actually intercept and replace something. So it's kind of right there on the cusp.
So I know when I played with it, when I wrote the interceptor, I had to actually specify the C# file name, the line number, and also the row into that file, just to specify exactly where that function call was made. When you said because it's experimental, it won't look like it currently is when it's in GA or whatever it's called, would we still have to do that?
That's an open question, but it's one of the things being discussed. Like, what is the mechanism for pointing into other code, right? What is the mechanism whereby we say that particular call? And there are a couple of options on the table for that. This one was the easiest to do on a prototype level. But regardless of which one we pick, it's not going to be super user-friendly. It's not going to be, there just isn't a good syntax for that. It's going to be ugly one way or another. Either it's going to technically line number, file line number, all that stuff is user-friendly in the sense that you can look it up and you can go and see where is that. But on the other hand, when the source code evolves, that changes all the time, right? So if you were doing it manually, you would then have to go back and update all your source generators all the time. So we're looking at, is there a more stable way of specifying that? Is there, but either way, it's probably not going to be a super useful, friendly feature for a meat programmer, so to speak.
So I've not done like a huge amount with source generators or Roslyn and expression trees and things. Is there an actual way, if you're doing that kind of code, that you can actually get the line number and the exact number of characters into the file so you can actually leverage this?
Yeah. If you're working with the Roslyn APIs, you can get all the details about the code. Like, that's a super high information, high fidelity model of a compile time model of code.
So even like where a developer just playing around with these interceptors and thinking, oh, I've got to type in the file name and line number. Actually, in reality, that code would be just referencing a property that's part of the Roslyn API.
Yeah. Whichever way we do it. The source generator that's working on the Roslyn syntax tree or semantic model, it would be trivial for it to obtain the information it needs to do the actual intercept. Like, whichever way we end up designing that, that's not going to be the challenge. There are many other challenges with building source generators and making sure they work in all kinds of, they're robust. It's not for everyone to build source generators, and I doubt it'll ever be. But this is not going to be the hard part.
I might have said expression tree instead of syntax tree before, but you know what I meant.
Yeah, it's the same thing.
So C# 13. I know there's a web page which I can include in the show notes. I think it's on GitHub in the docs, which shows like what's it called, like language feature statuses, which I had a quick look at. So I'll include that in the show notes. I've got to admit, I was hoping to see discriminated unions in there. Is that something that's coming in? Maybe as Scott mentioned before, C#, was it 39?
I'm not going to give you a version number, but I will say that we are working very actively in that. It's a very difficult, complex topic. And so what we are doing right now is that we've spun off a working group that's meeting every week that is chasing down the different sort of syntactic, semantic solutions and also implementation strategies for them. There are sort of two main flavors of unions. One is the kind that you might be used to from F#, where they're discriminated unions. You have like tags, name tags essentially for each kind of thing that a union can be. And then with each tag is associated a type of the data that you would have if you happen to be of that shape, if you will. And then there's type unions, which is more similar to what TypeScript has, where you just say, I'm a string or a bool, right? But you don't give them names. And that's also a very useful thing. So do we do one? Do we do the other? Do we do both? Or do we do one, but make sure that the design is thought through to be able to eventually embrace the other? And then behind all of that, what are implementation strategies that are efficient enough that people will not shy away from using the feature? Like we've had a few times in C#'s history, especially earlier on, where we did fabulous, elaborate features that had great usability, but that came with a performance penalty that is not as acceptable in today's world, right? It was essentially back when C# was only running on Windows machines. And so whenever we do a language feature, we have to take performance so seriously that people will adopt the feature without fear. That's, if you look at the collection expressions we just did in C# 12, that was exactly the design principle there. They're super convenient, beautiful, unified syntax for creating new collections. But if we had done that in a way that was inferior to what you could do manually, then people would say, well, for high performance code, I just can't use this. Like I have to keep doing something ugly and maybe something very ugly because otherwise the performance wouldn't be optimal. So what we are doing there is that we are letting the compiler do all the ugly stuff so that even though it looks pretty on the surface, there might be something very complex, a very gnarly, very low level, just so that your code is doing as well or better than you could have done manually. And unions have to be the same, right? Otherwise, they'll just start their life as a niche feature and they will never catch on.
Yeah, I guess with the performance thing as well, it's kind of, I guess you've got different target audiences. You've got the developers that are writing libraries and things for other developers to use, and they need to be high performance. If it's a bit ugly because they need to eke out every bit of performance, then that's okay. So they can use different language syntax than maybe just Joe Blogg's developer is using. So I guess like with these features, you probably got to look at like handle both use cases.
Yeah, I mean, sometimes we're happy to do a feature that is primarily for library authors, or maybe even primarily just for people writing the lower levels of frameworks. So we have, C# has always been like that. C# started out with an unsafe sub-language that you could turn on and off, just so that you could do interrupt or very high performance things at a lower level than most languages that C# is comparable to. And since then, we've created safe replacements for most of what unsafe can do. We have a lot of them are centered around span and around different use of ref and so on. So we've ramped all that up, and we are very happy for that to be a part of the language that not as many people use, because it's being used to build the high performance frameworks and libraries that then benefit the rest of C# users. But when it comes to something that is new expressiveness, like here you can write much more beautiful code, then having that be something that you should pause to use for performance reasons is just not good. Then it has to kind of reach all the way down. Like it has to be like 90 some percent of users will use it without any reservations, or at least without any performance-based reservations.
Yeah, I've got to say, with all the recent versions of C Sharp, that's the thing I've loved, how it's become more and more succinct, and you can have less code, and it's just, I don't want to say it's becoming more functional, but I guess it is, and it's just, I don't know, it just feels a lot cleaner. And yeah, even like with now you can have like a program.cs with all the stuff like global usings and what's the namespace where you don't get the indentation, and you don't have to have a program in your program.cs, like the class bit, so it can all be top level statements. And for new developers coming into .NET, I know like I'm currently working on a Kubernetes course, and there's a bit of .NET in there where I'm creating a minimal API to highlight like API calls within like a Kubernetes cluster, but I'm using minimal API to demo that. And a lot of the people watching the course won't be necessarily .NET developers, but it's so clean and small that I have no worries that they're going to be able to glance at that and understand exactly what it's doing. There's quite a few API endpoints, and it fits on one page, and it's really clean and readable, and it's just so nice the way that's going.
Yeah, I really love that particular round of cleanup, so to speak. I'm very proud of, also because it was done in close collaboration with the minimal API team, so it all kind of just clicked together. But I think when you have a programming language that's as old as C Sharp, the state of the art evolves, right? The C Sharp was it wasn't like the most terse, and it wasn't the most verbose in its time when it was created. It was somewhere neatly in the middle, right? But when the state of the art moves and people get used to cleaner, more concise code, you can either follow along, or you can say, nope, that's not the C Sharp way, and sit on tradition. And then pretty soon you find yourself being a legacy language. Like the approachability of C Sharp for modern programmers is part of what drives .NET's continued popularity, and it's part of what drives its accessibility to new developers. And so it really is important that we stay attractive from a language point of view as well, by modern standards.
Yeah, I guess as you mentioned before, when you introduce language features or syntax, you can't go back. So it's kind of, you've got to be really, really sure. I guess that's probably helps that it's open source and everything. You can get really early feedback. I guess one thing that springs to mind, which I've got to admit I was a bit upset that got dropped, but was the double bang operator.
Yes, that was... I think I actually like that story a lot, because I think it was let's just say it was an opportunity for us to demonstrate that we listen to feedback, and that we have a high bar for what comes into the language. It was a feature that everyone could agree that it was somewhat useful, but it was just not universally popular enough. It rubbed too many people the wrong way. And we don't want to put something in that's just good enough, right? It has to be the stellar best version it can be, and we have to work until we have that. And if we can't, then we just shouldn't go there. Then it's just not time yet. We have to have that long view and say, would we be proud of this in 10 years? And if not, well, maybe we just shouldn't do it. Maybe let's do something else that is beautiful and that's ready to roll.
I guess the use case I really liked with it was, so I'm a huge fan of expression body members. So if I've got any methods that are quite small, but obviously if I've got an assert checking that something not null, a parameter is not null, then it can't be an expression body member. But the double bang operator would have allowed me to do that.
Yeah.
So that's the bit I was looking forward to. But yeah, as you say, it's kind of like by not putting it in, that doesn't mean you can't put it in some point in the future. But if you do put it in and it's not quite right, then it's hard to come back from that.
Yeah, we're stuck with that, and we just raised the bar for doing a better thing later. So yeah, I mean, I'm completely with you. I was definitely in favor of this feature, and I would have used it all the time. But you have to look at the whole picture, and you have to listen to all the voices and make a good decision for everyone around that. And I'm not sour about that. I'm happy that we left more surface area budget for other things that are more universally admired or loved. So yeah.
Looking at the list of other C# 13 things, one's param collections. And I know I mentioned Nick Chapsas already, but I noticed he's done a video talking through this, which I'll include in the show notes. But yeah, this looks quite, like, I've not used params in a while, but it looks like it opens up more use cases for this.
Yeah, I think arrays sort of started out as being the built-in collection type for C#, the one that had deep support in the language. But arrays have a lot of problems. And so what you often find is that people who want to have that nice convenience of a params method overload, they will have an overload that takes the type that's actually the good one to use, and then they will have a params overload with an array because that's the only way they can get params. Well, why don't we just let params allow params on any collection type? Well, previously, an answer to why not might have been, well, we might not know how to create an instance of your collection type, but now we have collection expressions in C# 12. Now we have like established patterns for how we can tell on a given collection type which way to create it from a bunch of elements. Well, why don't we then go and use that in another language feature and say, well, params is really just like putting square brackets around the elements and do the same thing. All of a sudden, one feature enables another to finally come to fruition. Like people have been asking for other params things for ages. We've talked so many times about special casing it for one or two more types. Param span has been on the table ever since span was added, those things. And now instead, we can just do a completely general feature that just builds on the infrastructure and the concepts we already introduced with collection expressions, and it all clicks together nicely. So that's a really good example of sometimes a feature just has its time. It goes from being like gnarly and not worth it to, well, now something else is in the world, so all of a sudden it can just sort of beautifully happen.
That's so nice when that happens, when you've got one improvement or change or feature or something which suddenly enables lots of other things as well.
Yeah, it's so great. If I get only one of those with every release, I'm a happy man.
So a big open question now, and this is any version of C#. What's your favorite C# feature of all time?
I think for me personally, this is for personal reasons, but await is my favorite C# language feature ever for several reasons. One was that it was the first C# language feature that I was instrumental in making happen, and so I'm very proud of it. And also, it's been so successful that it's infected nearly every other major programming language on the planet. And so I feel like that was sort of a really important turning point for C# and for me personally. So, yeah.
I would double down on that as well, because not only did it affect, other languages, Mads, ASP.NET is full of this stuff. I mean, we basically asyncified ASP.NET with that feature. And so just seeing as we built the new .NET, especially as we took all these features and laid them across all the foundations of the newer tech, it's profound both internally and externally.
Can I just say, I just have to say that as I've been listening to Mads talk about, C# features and their intrinsic beauty, I'm totally getting that like Bob Ross aesthetic of like Mads sitting in front of his whiteboard saying, "Oh, that's a pretty little C# feature right there." It's great. I love it. I love the art that goes into the language design.
I do. It's funny though, because I think it's, and Mads kind of hints to this. Sometimes it's accidental as well. It's like, you do something and then 3 years later you look at it and you go, wow, that really is profound, just because of some other use case that kind of came up. And listening to Dan talk about ASP.NET, I felt the same way. It's like, we built web forms, MVC, web API, and it felt like we had this plethora of choices. And then who would have thought that this one thing we built, Blazor, a couple of years ago would coalesce and kind of take over all those things. And to me, that's that same beauty you're talking about in C#. I think it exists. It can exist in things like ASP.NET as well. And when we first thought about Blazor, we never thought, or nobody, I sat in the room with Steve Sanderson and everybody, nobody thought we were going to go, coalesce all the different kind of frameworks we have into one thing, basically one kind of rendering engine. So it's these kinds of things happen, beyond a C#. They happen across all the languages. I have a question for Mads and Dan. This would be a .NET 9 question. I was super excited that we have .NET 8 was the first version you could actually build a real AOT application. And that builds on some of the tech that we got from the Xamarin acquisition, some of the stuff we've done for Blazor. Are we going to take a step in .NET 9 so we can do more? I know dependency injection is one of the hardest things to actually, AOTize. And Mads is talking about some of the tech we've been doing in the languages. Do we think we'll take a step in .NET 9 and be able to do things like routing and stuff like that? Will it be able to be AOT'd, or how far away is that? Just if you don't know, that's fine too. I'm just curious.
I can share on the ASP.NET side, like we are definitely looking at the web UI layers of the stack, routing layers of the stack to understand like what would it take to be able to use native AOT on this part of the application. There are a lot of challenges. Like it's not a simple problem. I mean, even the minimal API work that we did in .NET 8 like involved again one of those massive cross team efforts in order to make that happen. At the like getting Blazor, for example, to be AOTable involves a number of technical leaps in terms of how we deal with reflection and how things operate under the hood in the stack. But we definitely have items to at least make progress on understanding how can we approach these challenges. What solutions do we think would be viable? Do I think we'll actually get to the point in .NET 9 where you can take a Blazor app and ahead of time compile it completely? I would say probably not, but we will probably have a much better understanding of the work that's needed in order to get to that point.
I think that's a really good answer. I think that something like AOT is a multi-release effort. And if you set it off in the wrong direction to begin with, it's going to be like pulling teeth to ever get there. But I think it's .NET 8 set it off in the right direction where we can keep iterating both on the things that have to build on top and have to be sort of AOT-ified, and also on the AOT technology itself so that more and more things can be included and maybe at lower and lower cost. So this is another great example of that synergy of the teams where we are evolving the layers together. And I think we will keep seeing AOT become more and more widespread and more capable as, a couple of versions down the road as we get there.
We should probably be clear about what we mean by AOT in this context, because particularly with Blazor, there's a couple of different scenarios that we can think about for AOT. Like we already support with Blazor doing ahead of time compilation of your Blazor code to WebAssembly so that you can pre-compile everything down to WebAssembly and ship it down to the browser so it runs much faster. What I think we're talking about now is actually the native AOT server scenario where I want to take my server application ahead of time, compile it, trim it way down so you get much better startup performance and single binary, better memory consumption and so forth. We do support AOT to WebAssembly already. AOT on the server involves a whole bunch of additional challenges that we'll be working on in .NET 9, but might not quite get all the way there.
And I don't want to overdo the AOT thing. I think it's interesting to me that one of the coolest aspects of .NET to me is the fact that over the years we've been able to make it work everywhere. It was Windows only, then it was Linux and ARM64, Mac. .NET is this platform that's really amazing because it touches all the types of apps you can build. And AOT is just kind of one of the final frontiers, and it's not something that we should take lightly. Many languages, as they go AOT, they break the language, or they say the libraries don't work anymore. And I think the .NET team's taken this really cautious approach and going slow and making sure that, you write your .NET app the same way you did before. You don't have to rewrite the whole thing in some weird way to take advantage of that. And AOT really only matters for super crazy scenarios. Like if you want to have as Dan was saying, a super small memory footprint, a super fast startup, super small on disk. Most of our customers don't need that. If you think about the big customers at Microsoft that use .NET, whether it's the M365 team or it's Bing or the back end of Teams, they're not trying to make 9 meg executables. They're trying to get the fastest platform on the planet so they can save costs in hosting that thing across. AOT is just me geeking out. I just want to just kind of say that. And so people on the call shouldn't be going, oh, I'll just have fun with you. I was giving crap to David Fowler at .NET Conf because they went and did this whole spiel in AOT, and I said, hey, you never said why somebody would want to use it. And so I just want to preface that and say, I would tell if you're a .NET developer, yeah, that's geek out tech. And the people that really want to use that stuff, and there are people inside of Microsoft that want to use that stuff too, they're willing to take the compromises that they need to do to use it. But .NET is so good just for general purpose apps today, you don't need AOT.
If you are one of those people, though, that feels like this is something you're interested in, want to use, like, please come and talk to us on GitHub. Like, all the work that I'm talking about in .NET 9, like, none of it's secret. It's all in tracked in GitHub issues for different parts of the stack that we're looking at. How could we AOT this? Like, come comment, tell us about your scenarios, because it does help us understand, like, where we should prioritize, like, how we should, make different optimizations to make that experience as useful as possible. So if you happen to be one of those specific people that Hunter's talking about, we'd love to talk to you.
Yeah, I think one thing you touched on then, Scott, with the fact that .NET can run anywhere, and that's one of the things I love about it, is kind of that you can build web apps, APIs, desktop apps, mobile apps, IoT, not AOT, IoT stuff, and it's just, you can do everything, and not a lot of languages or platforms can actually say that. One thing I did want to raise, which, because we've spoken about performance quite a bit in this conversation, is, I might be pronouncing his name wrong, but Stephen Taub's performance blog post. Oh my goodness me, I'm going to link to those in the show notes, but how long does that take him?
I think he writes it gradually over time. I'm not sure, but I believe he sits down and writes a bit of that whenever something new is in. You should probably have him on your show and ask him.
I would absolutely love to. I did actually reach out to him a while back, but I think he didn't reply. But he's done one of his blog posts about how async await actually works. And that would be quite an interesting, because it's quite a long blog post going into detail. And I thought that'd be quite an interesting podcast episode to actually dig into not just what async await is, but how does it actually work under the hood.
Yeah.
But then you mentioned before that you were kind of like quite key with async stuff. So that I'll just throw it out there. That would be an awesome podcast episode.
I agree. That's when I got to know Steve in the first place, was when we worked together on async.
That blog post is a funny thing for me as well. So I work on some of the AI efforts we're doing at Microsoft. And his blog post blows up my tech. And so I'm actually meeting with one of the teams today to go figure out why his blog post is the only blog post that I can feed into the tech. So basically the AI thing I do is you can feed Stephen's blog post in and then ask questions about .NET performance. And his blog post is the only piece of data that is so large that it actually crashes our tech out, and we have to go find out why.
That is hilarious. I thought at first you were going to say that he writes it with AI, but...
Sometimes I wonder if Tobe is actually behind some of the generative models that you think you're operating with a machine, but it's actually a Tobe back there, like just typing really fast and generating.
So a few days ago, I tweeted out, can I say that now? X'd out? That doesn't sound right. Tweeted out saying that we were recording this, and I asked if anyone had any questions they would like me to ask you. And it got a ton of likes, but only one person actually asked a question. So if it's okay with you, I'll just read it out. I'm afraid it's quite an open question, and I haven't checked the numbers to see if he's right. But this is from Suraj Kenchura, and he asked, Blazor has been out for quite a while, but hasn't seen traction in terms of adoptability by web devs, companies, and startups. What are we missing compared to other JavaScript-based frameworks? Now, I guess my first question is he right? Because my circle is quite .NET heavy, so I personally don't know what the uptake is outside of that circle.
Yeah, I can speak to that. So Blazor shipped for the first time with .NET Core 3.0. It's actually funny to me sometimes. We'll run into people who say, oh, Blazor's kind of new. I don't know. Is it okay? Has Microsoft really bought into this? And I'm like, well, it shipped 5 years ago now. So it's come of age, I would say. And I think in .NET 8, it really has come into maturity. It's a big moment, I think, for Blazor. It is growing very rapidly inside the platform. It's growing, I think, about twice as fast as the rest of ASP.NET Core. So it's definitely getting adoption. We use it internally at Microsoft for various internal line of business applications. We use it for our internal employee identity management system is built in Blazor. The trading compliance app, I think, is all built in Blazor. Lots of internal portals and admin sites. .NET Aspire, which is our new cloud native offering, the dashboard for .NET Aspire is all built using Blazor, and the Fluent UI, Blazor components. So yes, is it getting adopted? Yes, absolutely. There's some really great customer stories that you can go and read on the .NET site to see who's adopting Blazor. Now, if we look at broad web development, like obviously there are a lot of JavaScript developers and there's a lot of JavaScript investment out there. And is there a bigger JavaScript ecosystem than the Blazor ecosystem? I would say absolutely. Like JavaScript's been around for a while and it is the de facto language of the web platform. At Microsoft, we use JavaScript and invest in JavaScript ourselves as well. Like we have lots of our products that are built using React and we have, great tooling for JavaScript. We're actually at Microsoft a very multilingual company. Like we don't just do .NET. We do .NET and JavaScript and TypeScript and Python and Rust and
Java
and C++ and Java. Yeah, all these things. So there's options in the developer ecosystem, and you should certainly pick the language and the tools that make the most sense for your organization, for your application, for your requirements and scenarios. I would just say that I think with Blazor, you'll have a really great productive experience. Like we try really hard with Blazor to make it easy for you to get started, get going fast, use the latest features of C# to build your application, have a really great ecosystem behind it to be productive. Are there other options out there? Yes. And do lots of .NET developers use those options? Yes. And you should, evaluate and make the choice that's best for you.
Well, I'll just give my +1 with that. I've been using Blazor for all my apps now, and I absolutely love it. So any listeners, if you're not using it, then check it out.
I want to throw one more thing into that. I mean, Dan and I found something about half a year ago that was a blocker for some companies. They had some compliance tools that were not Blazor compatible at the time. This is that company in Texas, Dan, if you remember.
Is this DLL downloads?
SonarSource.
Yeah, SonarSource. No. This was a code cleanliness tooling with static analysis tooling for applications, and didn't at that time support Razor files, but they have since added that. Yeah, they've added that support.
When my point, Dan, is when we find things that cause people to not be able to use Blazor, we do go and take care of this. We found this at a big customer a couple months ago, and Dan got this taken care of. We also hear is it going to be silver lighted? And what I would tell people, what Dan said a million times on the podcast today, this is web tech. The web's not going away. So Blazor is just a web framework in .NET. And it's not a UI framework like a Silverlight or whatever. So web's going nowhere.
Another example of a compliance thing, which is what I thought you were going to say then, is one of the Blazor sites that a client are working on. We're using Blazor and Blazor WASM, and it was downloading the DLLs, and one of the users had issues with their company because it couldn't download DLLs. And .NET 8, that's now been fixed.
Yeah, that has now been addressed. Yes, that was, the way a Blazor WebAssembly app works, right, is you download a small .NET runtime implemented in WebAssembly to the browser so that you can then run normal .NET code, like normal .NET assemblies, which for historical reasons, are actually Windows PE files, which I think kind of freaks some people out when they look at the wire, like, wow, there's DLLs coming down on the wire. And yeah, they are. And they run within the browser security sandbox. So you can't run any code with those DLLs that you couldn't already run with JavaScript. And so that's it's a safe model, but a lot of some organizations' environments would trigger on seeing a DLL being transferred over the network in various different ways, and sometimes would cause Blazor WebAssembly apps to be blocked. So what we did in .NET 8 is we actually introduced a new packaging format where we take the .NET assemblies and we kind of strip the Windows PE file stuff off of it and repackage it as just a WebAssembly module. So when you publish your .NET WebAssembly code in .NET 8 and you look at what it looks like on the wire now, it just looks like a bunch of WebAssembly files. And as far as we've heard, that seems to have addressed that issue completely. If you're still running into problems, let us know. But so far, it's looking great. We call that WebCIL. Like there's was it .NET IL? This is WebCIL is the packaging format that we created for this.
Fantastic. So I'm strongly aware that I know you've got a hard stop in 1 minute. So we've 2 minutes. But yeah, so I don't know whether there's anything else that we've not covered that you want to talk about. I'm guessing 2 minutes probably isn't enough time to cover anything else anyway. But I just want to say, seriously, a massive thank you for joining me on the show and spending this time with me. It's been mind-blowing having you on and geeking out.
It's been a pleasure. Thank you.
Thank you for having us on the show.
Thank you.